joining. Using Hive, I can perform all this type of join. Inner join, inner join is common values, right? Then full join, a full outer join, I would say. Then left outer join or left join. Then fourth is right outer join or right join. Same thing, okay? If I say left outer, right outer, just the name is different. Then can I apply semi left join? There's other three other joins, okay, which are not there in your RDBMS, is map side join. Then you have bucket map join, bucket map join. When you bucket your data, right, using has functions concept, we have seen this in last session. So bucket map join, when you bucket any table and you perform joining on that bucket column, then your joining is faster because they uses the has functions concept to match the data. Then last eighth is my SMB, we call sort merge bucket join. Sort merge bucket join. So I need to first create the bucket, okay, and then I need to write the data in that bucketed table using sorting, sort by, okay, and then I can apply this joining. So this is all for performance thing, that when you apply map side join, bucket map join, sort merge bucket join, then they do not use any reducer for aggregation thing, okay. So far we have seen in the distribute by, cluster by, group by, order by, sort by, right, that 5 things. So they're taking more time to run the query because they're doing aggregation. They're starting one reducer and taking time. Now if I want to decrease my total time, I want to optimize the performance, then this 3 query is good for optimization. This 3 is good for optimization. I'll be checking this 3 after this 5. So let's start with the inner join, and for that I will go to my Cloudera machine, open a Hive cell, so both the flavor we know now, right? How GCP and Cloudera works. I think we can work with both. Just the difference is execution engine. So when my execution engine is high, is TZ or a Spark, anyways, my performance is already high. Then no need to work all this concept, but this is all applicable there also in TZ execution engine. And yeah, one more thing we need to discuss today is a Hive different execution engine, Tej versus MapReduce. So that one line difference I will tell you once we complete this part. Let's go to Hive. And I'll open my folder. Practicals.pdf. So we did till this part. I will start from here. Find find cells based on the each group. So I'll be creating this table from here. So databases, use database, so tables, so many tables, let me delete which I don't need, drop table, cat, I don't need. Drop table cat, what it says, cannot drop a view with drop table. Okay, sorry, drop table, drop view cat. This is a view, that's why it's giving error. Drop table alert. This is also a view, so this is a table. So tables, this verification, yeah, that is good. So let's go and run a query of Hive creation table. So I'll copy this, create table customer. We're creating one customer table with row format delimited, fields dominated by, and we're loading the file. Okay, so do we have this load cust file? I think this is present in my desktop. So I'll go to my desktop and see this cust. Can I open this and check using vi command? How many total rows are there? So almost 10,000 data we have. Okay. Then what is the query to load this? Load data local in path home Cloudera desktop and file name, which is first into table name, which is customer. Now what it says, load data local in path, into table name. Can I run select star from table name just to validate this data? Select star from table name, limit 10. Do you have any result here? So result is all present in customer table. Now I will create another table. I'll tell you the idea what I'm trying to do. So I want to do a joining, and whatever records are common after joining, I want to write that common data into another table. That's what is my idea. Create out one table, row format delimitation, is dominated by, enter. Now we'll run this query to check the table. Customer is having data. Out one is a blank table. Now this is the fun part. So in this query, what I'm doing, let's read this first, then we'll submit it. In previous operation, I have just created two tables. In one table, I have loaded the data, and second table is a blank table, just present with a TDL. Now I'm saying insert override table out one. So I want to write data in this table. I want to write this data on this table, and I'm getting this customer number from where? From A, alias A. And what is A? A is my customer table. Just a few minutes ago, I have created that. So customer number I'm getting from table 1. First name I'm getting from table 1 again, because A dot A is my table 1. Age I'm getting again from table 1. Profession from table 1. Amount from table 2. Product from table 2. So 3 columns from table 1 and 2 columns from table 2. I'm getting this data. What is the table 2? This is a table 2. TXN records. Way back we have created this table in step number C in the same file. Okay. So this is my table 1, this is my table 2, and then I'm running a condition that whichever customer number is matching, this is my condition. Whichever customer number is matching in both the table, fetch all that record. Get me all that data. Now before doing this, can I check how many data is present? Can I run this simple query first? Okay, so let's run this query in my Hive cell. Since both the table is present now, I can run this query. So let's go there and check their field name, desk, txn records, and desk second table name, which is customer, desk customer. So customer, this is my joining column. Okay, common records if I have, I'll get it. First name I'm getting from table customer, last name, age, and profession. And then from here I'm getting maybe what we have, profession, amount and product, okay. This is the query. Select a dot first name, a dot last name, a dot age, a dot profession, and b dot amount, b dot product. This is table 2. From what is table 1 name, customer a, comma, customer b. What is the customer b? Is txn records b, where a dot cust number is equal to b dot cust number. Enter this. So I can run this query, and after this I will take another query to get the same output. So my job is started with the number of mapper 1. Reducer is 0 because I'm not doing any aggregation. I'm just getting the common result. If I'm doing group by or something, then this reducer will start. So almost 49,995 results are matching, okay, on this customer number, and this is giving us that data. Okay, so this is the total number of result, and now I want to write this total number of result in out1 table. Okay, so just one change in my query. I'll say insert override into table, insert override, I think directly I'll say table, override table 1, which is my out1. This is the query, and this query we have seen. I can run another query like this. From table 1 join table 2 on. So just instead of comma I have used join, and instead of where I'm using on. You can see it here. It will give me, by the way, same result. Okay, query is not getting me different result. The query is exactly same. So once the data is imported in this table, we'll go there and check this count star thing to check the total output. So you can, I think you can see this total read this HDFS, write this in bytes, which is total size of this. And to check this out, select count star from table 1. This will take another 1 minute or maybe 30 seconds. Now you can see, since I am giving count, that's why the reducer is coming here, because this is aggregation query. And total result is this only. We have seen that at top, 49,995. Okay. So next operation, what I did here, I just joined two table and taken common data. So this is like an inner join. I'm doing inner join on this. This is inner join. I'm doing inner join on this two table and getting the common result here in this out one table. Then similarly, I will create another table, which is out two table. What I will do in this out two table, I will tell you that level string, row format delimited, fields dominated by. Table is created, out to table, right? Now, after this is a blank table. So again, I'm doing one case class this time. So I'm putting a case. In Hive, I can use this case. If you remember the case we have seen in C, C++ also, switching cases, right? So this gives me condition. Let me write this query, then output I will tell you. Insert override table. So I'm inserting on this table 2, which is out to table. Based on this query, select star means taking all the data. This star means taking all the data. Table I will define. From which table? When age is this, then second age is this. Third age is this. And fourth else is this. This is like if else condition. And in the query and from out one. Before running this query, let's understand this. Now in my out one table, if I go in my out one table, my out one table and my out two table has the same definition. Can you check it? My out one table has how many columns? So customer number, first name, age, profession, amount, product. Now the 6 is common. I'm adding one more column here, which is a level column. And what I'm doing in this level column, I'm saying people who are more than this age category. Okay, in this query, I'm saying people who are more than. So insert override table 2. This is my target table. Select a star. Star means take all column from this table, which is my source table. case, case and end of the case. This is boundary. Case and end of the case. This is the boundary, and within this, you're creating a condition saying age. People who are aged more than 30, sorry, less than 30, are low. As a young age, I can give this any value. Okay, this is defined by me. I can write anything here. When age is more than equal to 30, end. This is like an end operator. If I write the same thing in if else condition, we write this: if age is less than 30, right? If I'm writing in a Python sense, then we call this print low. Or if I'm writing in Java Scala sense, we do the same thing: print low. Then I'll say elif, right? There we use elif, nested if else condition. Elif, when age is more than 30, and we don't write end as this sign, we use this operator, end operator. So I'm just relating this query. Age is less than 50, then print middle. Similarly, elif, when age is more than equal to 50, okay, then uh, instead of then, I'll say print old, and then else, the last condition, else is print others. This is what I get, what I do there. The same condition I'm writing in other sense, but logically, if you think, this is what it is doing. Age is less than, age is in between this, age is more than this, then else others. If nothing is matching else others, in from out one from this table, and this is my query. So I can use these cases in Hive. Enter. Okay, output is there. Can we go to see the output in select star from out to, or total obviously 49,995 records will be there because we're taking all the column and we're just giving a condition, so must be having all that result. Select a star from out to limit 10. I'm getting null in my first column. Oh, I'm getting null. One second. 1, 2, 3, 4, 5, 6, 7. Okay, so desk out to customer number is not coming, looks like. Why customer number is not coming? Let me check it. Out to customer integer. So what is desk out 1? By the way, this is also same. Profession amount, product label. Do we have null data there also, or it's just coming here? I'll validate this in my HDFS location. HDFS DFS minus ls user hive warehouse database name table name out to and 000 star. cat, and I'll say first few result is a hit. Okay, so it's taking like new line slash n. Here itself, this is not taking it. Let me see the error. Maybe I write all the column one by one. Then will it work? Select the star from out one, limit 10. The problem is this table itself. It is this table itself is holding null data. My source table, that's why it is coming here. So problem is with first table, out 1, 0, 0, star. Sorry, head. This is a problem. What is happening in out one? Select and set a cust number. So A is my customer table. In customer, if I check this, customer cust, one second, what's the problem? Cust is fine here. Let's prescribe me for customer. Okay. So there is a mistake. Customer number is a string. Okay. That's why it is coming as null. So anyway, we'll change this customer number from, okay, this to, we'll alter this. Let's say first we'll alter in the customer itself. So my first customer itself is wrong. Alter table, which is customer, alter table name, change column name cust number, column name cust number is still, but I want to change this to integer. Okay. Now can I run select a star from customer, limit 10. Perfect. So this is good now. Select a star from integer, sorry, out 1, limit 10, desk out 1. I need to reload it, okay, by the way. So records are fine now. Desk cust customer, this is integer now, and I will run this query again. I will run this query again. Out one table, I'll reload this data. Insert table, insert override table, table 1 cust And by the way, if you see here, missed out I've missed out the customer number also. So I missed that first a.cust number, which I'm taking from customer. This was missing in my query. No problem. Cannot insert in table types, different outbound table, 6 column, but query is 7 columns. 1, 2, 3, 4, 5, 6, 7, 5, 6. What is missing? Last name is not there. We'll wait for another 2-3 minutes and we'll revalidate this. Okay, select star from alt 1, limit 10. Should be good now. So yeah, this is good now. And the last query, select case query. So inside override table out to select a star, case when age, all are good. I'll just do one more thing before moving to my query. I'll do desk out to. Select a star from out to, limit 10. So this is good now. Okay, sorry for the silly mistake. This is for customer number, and this is all my new level column. Based on the age, we can see. So if somebody is having age 43, it's middle. If it is more than 50, it's old. Okay. Do we have any others? So I'll run one more query where I'll say where level is equal to others. This was others only. Level is equal to others. We don't have any others, by the way. All the results are having some value in the range which we have given. So this is about your out2 table. Then I'll create another table as out3 table. This is my third table, having level and amount, just two column, row format delimited, and fields terminated by table created. And then we're inserting on this table out3 from table 2 out2, and we are summing the amount based on their level. So it's like we are using a group by condition, right? What this group by will do? This group by will create total 3 labels, because this label is having 3 outcomes. One is low, one is middle, one is old. So it will create 3 because this group by will convert in key value pair. This is my key, and this value will be the total amount, which are uh, for only low. So if there are total 100 low, it will aggregate and tell the to output here. Similarly for middle and for old. So level will be coming like this, and then it will aggregate me the total sum and store this result in table called out3. So earlier was simple joining query and then writing to your table. This is my aggregation query and then writing this information to the table. So insert overwrite table out3, select level sum. Sum is aggregation, amount from table out2 group by level. So all good. Enter. This will start a reducer for sure because I'm using group by along with sum. You can see it here, number of reducer 1. Okay, now check this result. Select a star from out3. So just 3 rows and their total amount. So old category is having highest, I guess. 1, 2, 3, 4, 5, 6, 7. This is just 6. This is also, yeah, old is highest. This is second highest. This is last. So this is just one query to take that aggregated outcome and store in another table. So whenever you want to do this, you can use this insert operations. After that, we'll start with our this joinings. Inner we have seen, now left, full right, full outer right, and semi. For simple join, I will create one table, and before creating table, I'll create the data. So here in my desktop location, I'll create one file named emp.txt, and in this I will write all this result. Comma separated value. Control D, file created. Another file I'll create as email.txt because I want to perform joining on this too. These are the name and email. Once again, it's Gmail, Yahoo. I'll change this as another domain. Let's say this is coursera.com. Enter. So two files, emp and email. Now I'm creating one table. So this table I'll create in my Hive cell. Fields terminated by, and loading the file. So load data, local in path, home, Cloudera, desktop, and this file name is emp.txt. Names I'll name this into table employee. Select a star from, just validate employee. So these are the result, three fields. Similarly, I will load on second in path. Let me change the path directly. Sorry, second table is not yet created. So first I will create the second table. Second table is mail ID. Row format delimited, fields dominated by. Then I'll load data on this table also. Load data, local in path. This is, I guess, email. We correctly spell email.txt. Table name is mail ID. Enter. Select the star from mail ID. So we get this result. Two rows, and these are the result. Now, first query, I'm searching for this. Select the star from this is simple where condition query from where he belongs. This is my joining. This is my inner join. Right. So inner join, I'm saying get name from table one. Get name from table one. City from table one, salary from table one, email from table two, and inner join on this name. This name itself. So when you do this inner joining, okay, it will start submitting this job on again MapReduce. Okay, so just two result is common in both the table. Two name is common. This is Sweta and Tarun. Because if you run a simple star query also, you'll understand this, how many result common. Looking at this, I can say Sweta and Tarun is common in both. This is inner join, then can I apply left outer join? So this is table from, this is table employee A, Instead of writing join, I'm writing this left outer join only. Okay, this is just one thing. Now, what is the difference between inner join and left outer join? So left outer join, I think you already know, but I'll invest one more minute here to explain. Left outer join will bring all the record from left table, which is my employee table. It will get all the data from this table, okay, and only common data from this table, mail ID, which is this. So I'll get all this result, Sweta, Anamika, Tarun, Anita, along with this result, okay, along with this result. But from this table, I'll only get this two, which means there will be one more column appended here after this joining, name, city, salary, and one more column will be there, email column after running this query. But email only we have for two, which is for this result and for Tarun, third result. How about this? This will come as null, null, and null because there is nothing. So left outer join means all the data from left table, and what I'm telling as a left table or referring as a left table, my first table is a left table. So whenever I define table 1, table 2 in my query, this is my left table, this is my right table. Okay, so we'll be calling the significantly left and right as we go forward with other queries. So you'll see the result all from employee and only few from this mail ID. Similarly, I'll apply right outer join also after this. So one changes only in this all column. In all query, if you see, instead of left, I'm changing right, and rest all things the same. Route right means get all the record from table 2 and only few from, as in common from table 1. You can see Sweta and Tarun has mail ID, other has null and null because by default null is there in Hive. Let's do this right joining and same column I'm using. Now this time I'll get uh, this is the right now. So I'll get name and mail ID for all, and salary and city I'll only get for Sweta and Tarun. This will be blank and blank. Okay, the result is here. Only mail ID we're getting for these two people. Then name, and other all result is only for two, but only this is having uh, mail IDs. Other things are missing for them. So this is about your right outer join, and last is full outer join. Full outer join means take all the data from both the table, complete record. If it is present, give me. If not, give me null. So only two results will come full. All will have some null entries. Okay. Rest will have some null entry because uh, Nagesh is present here. Name is not there. Venkatesh is not present. Yeah, that's okay. Now, this is about your basic joining. We're still pending with four optimization joining. Semi-left join, map side join, bucket map join, sort, merge, bucket join. Before this, I will explain you one difference between TEZ and MR architecture before moving to joining side. So in TEZ, flow is same. Okay, the flow as we have seen. Okay, let me create the flow for MR first. MR flow in Hive query. Interface. So we're running all this query from interface, which is going to driver, JDBC driver, which is going to a compiler. Now compiler is going to metastore. Metastore is going to again back to compiler. Compiler is submitting this query to execution engine. Then execution engine is submitting this to resource manager, which is part of Yarn. Resource manager is submitting this to number of node manager, where we have data node available and multiple CPU processing based on the multiple task. Suppose I have another node manager. This is one, this is one, this is two, this is two. Again, they have some multiple CPU processing it, going back to execution engine, to compiler, to driver, and getting output here. Now, one difference only in TZ. Okay. So one in last time also our 90% query was right, and only the difference is this interface I'm running in page interface. They're also doing the same thing. They're going to driver, they're going to compiler, they're going to metastore. From metastore, they're going to back compiler, then execution engine, processing in resource manager, given detail by Yarn, and then they're processing in node manager, which is having CPU, data node 1 and M1, data node node manager 2, data node 2. Only one difference there, they are creating a map task and reduce task if required for aggregation. This two thing is created in the flow of MR. Here I'm creating map vertex. Okay, this is what I was talking. Map vertex and reduce vertex. I'll tell you what is a vertex. Since they follow TEZ, follow DAG directed acyclic graph, this is a cyclic graph. I can call it DCG, right, or interactive processing. So DAG can keep their data in memory, in memory, which is a RAM part, and this is a on disk computation, on disk computation. So this is memory intensive. This is a memory intensive operation. This is a disk intensive operation. This is actually found by Hortonworks in early days, I guess 2000, after 2012. I do not remember the exact year, but after 2012, after Yarn thing, we get this by Hortonworks, okay, which is currently merged with Cloudera and their same company. MR is this concept was found by Google people, right? GFS people, and Google Research Analysis System started working with this. Then UC Berkeley, AMP Lab, and other different labs, we built this. So TZ is actually good for both. TZ is actually good for both. It can handle your historical data, like batch data, and it can handle the real-time data also because they're memory-intensive operation. MR is only, this is why MR is failing, okay, terribly here. When I compare them, it can only do this disk operation, and it can only work with the history data, not with the real-time data. That's the main difference I found here in TZ and MR. Now, interesting factor will be what is the difference between TZ and Spark. That will be our interesting part to discuss. So when the right time will come to discuss difference between Tej and Spark, we'll see that.